Welcome viewers. Today we'll be looking at base 10 and base 2 numbers. What we will be looking at in this particular case is converting from base 10 to base 2. We are mostly familiar with base 10 numbers, and our everyday calculations, our everyday numbers we see around are commonly base 10. In the base 10 number system, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 in the base 10 number system. So there are 10 numbers in the base 10 number system. And as we can see, funny enough, the number 10 in the base 10 number system is actually 1, remainder 0. 1, remainder 0. If you have a number 20, it's actually 2, remainder 0. You will notice that in the base 10 system, for instance, you have 549 into base 10. You will notice that none of the individual components of this number system is actually 10. I'm talking about the 549. If you look at 45, also in base 10, you will notice that none of these individual numbers or components is actually a 10. So they're all usually smaller than 10 itself. Also, if you look at 67, none of these individual numbers is actually 10 or greater than 10. They are usually less than 10. Let's just look at that practically. You see the 5, less than 10. You see 4, less than 10. And then you see 9, less than 10. Also in 45, you see the first component, 4, or digits, less than 10. And then you see 5, less than 10. And that's the same thing you see for 67. So like I said earlier, each of the figures is usually less than the number base. Now 549 can also be simply 549 or 549. You don't necessarily need to put the base 10 because these are commonly used every day, just like 45 also, and just like 67. But for the purpose of this video, we will be putting it in base 10 such that we know it's in base 10 and we are converting it to base 2. Now here we are looking at base 2. Base 2, your numbers in base 2 are 0 and 1. 0 and 1. So you have two numbers, 0 and 1. Note that it doesn't get up to 2. It doesn't get up to number 2. The moment you get up to number 2, it now becomes 1, remainder 0. 1, remainder 0. So you have two numbers, 0 and 1. It doesn't get to 2. The moment it's almost getting to 2, because it's base 2, it now is 1, remainder 0. Now, base 2 numbers are commonly used in computer numbering. Here you have 101, all in base 2. You see that all the individual components are usually less than 2. All the individual components of the numbers are less than 2. You see your 1, less than 2, 0, less than 2, and also your 1, 101, they're all in base 2. Similarly, you have this 10 there, it's also in base 2. Likewise, your 1, 0, 0, 0, 0, 1 also in base 2. So that's what we have, examples of base 2 numbers. So we will be looking at how to convert 549 in base 10 to base 2. We will be converting 549 in base 10 to base 2. When you're converting from base 10 to any other base, for instance, you're converting to base 2, base 3, base 4, whatever base, what you simply do is to divide the 549 into that number base. So now that we are converting to base 2, we will divide by long division 549 and we will be dividing it by 2. So let's just write 549 as we can see at the top right, and then we begin to divide it by 2. 2 in 5 is 2. You remain 1. So that remainder 1, we can simply put it by the 4. So now we have 2 in 14. We have 7. There's no remainder again. 2 in 9, we have 4. And it now remains 1. Because 2 times 4 is 8. And 9 minus 8 is 1. So that's where we have the remainder of 1. Now we divide by 2 again. 2 in 2, 7, 4. So we go 1 by 1. 2 in 2, 1. 2 in 7 is 3. Remainder 1. So we put that 1 here by the 4. 2 in 14 now becomes 7. And there is no remainder. So remainder 0. Now we divide by 2 again. 2 in 13 we have 6. 6 times 2, 12. 13 minus 12, 1. So we have a 1 remainder, so we put it by the 7. So now 2 in 17, we have 8. And if you multiply 8 times 2, you have 16. So out of the 17, we have 16. So we have a remainder of 1. And that's why we put R1. Next, again, we divide 68 by 2. So 2 in 6 is 3. 2 in 8 is 4. And we have 0 remainder. Now we divide by 2 again. 2 in 34 is 17. There's no remainder. So R is 0. 2 in 17, 8. 8 times 2 is 16. So you have a remainder of 1. 2 in 8, you have 4. And then there is no remainder. So the remainder is 0. 2 in 4 is 2. And there is also no remainder. Remainder is 0. 2 in 2 is 1. And there is also no remainder. So what we do also is now to divide 2 in 1, 0, and the remainder is 1. Now, our conversion from 549 in base 10, that is 549 in base 10, to base 2 is actually staring at us in the face. The answer is staring at us in the face. So what we simply do is to extract the numbers from the base to the top, and that gives us the conversion from base 10 to base 2. So picking up the numbers from the base to the top, we have 1, 0, 0, 0, 1, 0, 0, 1, 0, 1 in base 2. I come again. We have 1, 0, 0, 0, 1, 0, 0, 1, 0, 1 in base 2. And that is the conversion of 549 in base 10 to base 2. Now let's look at another example. We have 45 in base 10. That's 45 in base 10. And we want to convert it to base 2. Like we said earlier in the previous example, what we simply do is to divide it by 2. when converting from base 10 to any other base, for instance, base 8, base 7, base 6, base 9, what we simply do, or even base 2, as this case may be, is to divide by the number base. So let's write 45 where we can see it there. And then since we're converting to base 2, we divide by 2. So 45 divided by 2, 2 into 4 is 2. 2 into 5 is 2. But there's a remainder 1. We divide by 2 again, 2 into 22. 2 into 2 is 1. 2 into the other 2 is 1. And there is no remainder. So remainder 0. R represents remainder. So 2 into 11, we have 5. So we have a remainder of 1 because 5 times 2 is 10. And what we have there is 11. So 11 minus 10 is 1. So the remainder is 1. So 2 into 5, we have 2. And then we have a remaining 1 because 2 times 2 is 4. But what we have there is 5. So 5 times 4. Sorry, 5 minus 4 is equals to 1. And that's where the remainder is. 2 into 2 is 1. So there's no remainder. So R is 0, remainder 0. And then 2 into 1 is 0. And the remainder is 1. So like I said earlier, the answer through the remainders are actually staring at us in the face. And what we simply do is to pick up the numbers from the bottom to the top. And when we do that, we have 101, 101 in base 2. And that is the conversion of 45 in base 10 to base 2. Let's look at one more example, 67 to base 10. And we will be converting it to base 2. So like we did earlier, we divide by 2. 2 in 67 is 33 remaining 1. Because if we multiply 2 and 33, we have 66. But what we have there is 67. So 67 minus 66 is 1. 2 into 33, 2 into 3 first, we have 2 in 3 is 1. And then we carry over the 1. So 2 in 13 now becomes 6. So we have a remainder of 1 because 6 times 2 is 12. And what we have there is 13. So our remainder is 1. 2 in 16 is 8. Without any remainder, remainder is 0. 2 in 8 is 4. Without any remainder, remainder is 0. 2 in 4 is 2. Without any remainder, remainder is 0. 2 in 2 is 1. Without any remainder, the remainder is 0. And then 2 in 1 is 0, remaining 1. Our answers are staring at us in the face. What we do is to take the numbering from the base to the top. And that gives us the conversion from base 10 to base 2. So what we simply have 67 in base 10 is 1000011 in base 2. And that is the answer to our conversion of 67 in base 10 to base 2. So we had 3 questions where we were converting from base 10 to base 2. The first is 549, the second is 45, and the third is 67. And like you can see at the last column on the right hand side, we have the conversions from base 10 to base 2. Thank you for watching this YouTube video. I believe it has added some value to you. Kindly subscribe, kindly like and share.